This pyruvate then eventually gets converted into acetyl CoA. Okay, this acetyl CoA can enter into the Krebs cycle. Okay, how they can enter into the Krebs cycle? They can combine with oxaloacetate. Okay, to form what? Citrate. Okay, so this citrate then becomes cis-accotinate, isocitrate, then alpha ketoglutarate. It just goes on and on and on. This cycle just continues, and finally what happens? You generate oxaloacetate. Okay, and in the meantime you release more amount of energy. Okay, various kinds of high energy intermediates. Okay, so these high energy intermediates will get eventually used up inside the electron transport chain, and this in turn converts those high energy compounds into ATP, and in this way your body converts your body uses glucose as a source of fuel for synthesis of ATP. Okay, so this is what happens normally for a normal person without any kind of a problem or any kind of a pathology if he is on normal diet. Okay, now imagine this scenario in which this patient, our case interest here, has very low glucose in his cells. Okay, so low glucose in his cell, it could be either due to decreased glucose intake, okay, or it could be due to decreased glucose intake as a food, okay, or it could be due to decrease in the availability of receptor for taking the glucose inside the cell, something like diabetes mellitus. So in both these conditions, what happens? The amount of glucose level actually comes down. So glucose level comes down means what? Body naturally will have very low amount of ATP at that time. So at the same time you will be having low glucose. So low ATP as well as low glucose. So your body thinks to counteract these two by two new cycles. First thing, it tries to restore your energy for the muscles or for the various other kind of tissues in your body. How to restore the energy? By inducing an alternative source of fuel. So what is the alternative source of fuel present in your body? It is nothing but lipids, which are there stored in your adipocytes for exactly for this purpose only. So there will be more amount of lipolysis, and because of this lipolysis, what happens? Increased amount of free fatty acids will be generated. These free fatty acids will circulate in your blood. They finally reach your liver, and there in the liver, these free fatty acids will get converted, will get they get metabolized for the formation of energy. Okay, for the formation of energy in all other tissues. Whereas in case of liver, this free fatty acid will get broken down into smaller compound, the basic compound called as acetyl CoA. Clear? So now you have got more amount of acetyl CoA influx from increased lipolysis. Increased lipolysis causes increased amount of acetyl coenzyme A formation. At the same time, what happens? Our body has two issues. One is low ATP, second issue is low glucose. So in order to counter that low glucose, what our body does? Your body starts gluconeogenesis mechanism. In gluconeogenesis, what is the main requirement? You need to have oxaloacetate. Oxaloacetate, all this thing will take place in the mitochondria. So this oxaloacetate must come out of the mitochondria. So it combines with malate. So it gets converted into malate, and this malate can come out of the mitochondria, and this malate shuttle, you finally regenerate oxaloacetate. Okay, so this oxaloacetate in turn gets converted into phosphoenol pyruvate with the help of what? PepsiK, phosphoenol pyruvate carboxykinase. PepsiK, this gets converted into phosphoenol pyruvate. This phosphoenol pyruvate in turn helps in glucose synthesis, gluconeogenesis from non-carbohydrate source. So you have two simultaneous cycles which is getting apart at the same time, guys. One is increase in the amount of acetyl-CoA. This increased acetyl-CoA then enter into the Krebs cycle for generation of ATP. Why there is an increase in the acetyl-CoA? It is due to increased amount of lipolysis from your adipocytes. At the same time, what happens? This oxaloacetate, our body tries to utilize the amount of oxaloacetate for the formation of glucose through gluconeogenesis. So, the same cycle is is getting used for two different things. One is for generation of ATP, another one is for generation of glucose. So, now you have got increased supply of acetyl-CoA. The supply for acetyl-CoA is continuously there, whereas the supply for oxaloacetate is not available. So, because of this, what happens? After some time, there will be a depletion in the oxaloacetic acid levels. So, once the amount of oxaloacetate comes down, what happens? This Krebs cycle, this citric acid cycle shuts down. It stops. Okay. So, once this thing is stopped, what happens? You will be having even more accumulation of acetyl-CoA. All other cells in your body can utilize free fatty acids as an alternative source of fuel, except for the two organs which are nothing but your RBCs and your brain. Okay, they rely on only glucose as the only source of energy. Okay, so these free fatty acids, your body may break various amount of numerous amount of free fatty acids, but those things are not going to be useful for your brain. Now, you have got more amount of acetyl-CoA here. The acetyl-CoA is high, and this acetyl-CoA now will be utilized for synthesis of an entirely new compound called as a ketone body. This ketone body can enter inside the brain, okay, and they can be an alternate source of fuel for your brain cells. So, this is how this acetyl-CoA is getting converted into ketone bodies. So, we have got more amount of acetyl-CoA, right? Excess amount of acetyl-CoA inside your liver. So, all this acetyl-CoA tries to get together. So, one acetyl-CoA combines with another acetyl-CoA. So, this gets rid of one CoA. Now, this becomes acetyl-CoA. So, this acetyl-CoA has got how many carbon atoms? This has got 4 carbon atoms.